Hello, everyone. It is about 8:30 a.m. Thursday, March the 22nd, and this is DelRayVAWeather.com. Okay, I'm going to do a little video to discuss the snowstorm that we had yesterday, the unusual March snowstorm, where Washington Reagan National Airport got 4.1 inches of snow. And I always do a post-mortem after the storm to see if there are things I can do to improve the snow ranges that I predict and the timing and things like that. And if you remember, my final snow range for the storm was 1 to 3 inches. That would be what would be at Reagan National Airport. And since we got more than that, we got about 1.1 inches of snow. I did bust, and so I want to find out why I busted that to that extent. And playing around with a few figures, I think I may have found an algorithm that may actually produce a more accurate snow range in the future. And it's based on the European model EPS. That's the ensemble model. What they do is they run about 50 different tries with slightly different parameters, and then come up with a probability map of the probability of snow being more than an inch, more than 3 inches, or more than 6 inches. And I started to look at that, and in fact, I used that model to come up with the 1 to 3 inch boundaries for the snow ranges, but I didn't actually go into a great depth. I basically took what the probabilities were for the last run about 36 to 48 hours away from the event, and used that to set the range. And this morning I dug a little deeper, and I found a technique that might work actually better. And so first of all, I'm going to show you the probability map that the EPS produces. And this is currently set for about 8 p.m. on the 21st. That would be what the total amount of snow would be by 8 p.m. On the 21st. And 8 p.m. was essentially the end of the storm. And it actually, everybody realized that the 8 p.m. was going to be about the end. That National Weather Service Monday set that as the ending for their winter storm warning. So the ending was pretty well established. Okay, this shows, let me move this to here. This is the probability as of that model run, and this is the midnight run this is the noon run on the 19th. And it shows, this is Alexandria, DC here. It shows that actually Alexandria and DCA had 100% probability of getting more than 1 inch, pretty high probability. If we change this to 3 inches, we see that we have about 84% chance of getting more than 3 inches. And as far as 6 inches are concerned, we had about a 36% chance of getting more than 6 inches. And this run was, between 36 and 48 hours before the actual start of the storm on the 21st. Okay, so what I did is I looked at the 4 runs of the EPS. That's the midnight and noon runs on the 18th, the midnight and noon runs on the 19th, and wrote down all of the percentages for the different values of snow. So here it's showing 88% chance of greater than 1 inch, 62% chance greater than 3 inches, and 34% chance of greater than 6 inches. So we got this set of numbers of probabilities for snow greater than 1 inch, greater than 3 inches, and greater than 6 inches. Okay, I then took and calculated the value of less than or equal to 1 inch, 3 inches, and 6 inches, and came up with this set of figures. So again, less than or equal to 1 inch would be 12%. probability, 3 inches, 38, and less than 6 inches, it was 66. Okay, now what you can do, there's a technique called weighted average, where you can take weights for different values, values that you think are going to be more probable or less probable, and then you'll be able to calculate a mean value that is more related to what the probabilities of those different values would be. And I should say that this is not going to be using strict probabilities. It's only using the probabilities as weights to calculate the values. And so in the case of these 3 sets of numbers, what we're doing is taking probability of less than or equal to 1 times 12, less than or equal to 3 times 38, and the same for 6 times 66. So we come up with this formula. So it's 12 times 1, 36 times 3, 66 times 6. And then what we do to produce the denominator is we add up all of the weights, 12, 38, and 66, come up with a sum, and divide that into the values we calculated in the numerator. And in this case, it came out to 4.5. Now, if you add up those numbers, it's 114, not 100. So we're using these as only weights, not probability averages. Okay, so we do that for each of the runs of the models, both for the greater than and less than and equal to sets, and we come up with a set of 6 different values, the greater than values and the less than values and greater than values. And then what I did is I averaged those values. So in the case of the greater than or less than values, we have 4.86. For the greater than values, we have 2.61. And then I also calculated standard deviations for both of these. That would be the standard deviation of these 4 figures, 4 runs of the models. In the case of greater than, it was 0.1. And again, standard deviation of these runs of these numbers, and came up with 0.48. Okay, then what I did was, first of all, I took these values, in this case, the greater than or equal to, I took and subtracted the standard deviation, and for I should reverse it. This is this is greater than or equal to. Subtracted the values, and the less than or equal to, I added the values. So we came up with 2 numbers. The lower boundary in this case would be 2.5, and the upper boundary is 5.4. So if we had chosen this as our range, 0.5, 5.4, the 4.1 actual total actually would have fallen in. It would not have busted. So I did one other thing. I decided to try and narrow the range and see if it would still work. And the way I did that is I simply took the lower boundary shown here and the upper boundary shown here, and ended up, let me see if I can get this out of it. Ended up with numbers of 2.6 and 4.9. Again, this would be an accurate value for a range for snow for Washington Reagan National Airport. And unfortunately, this is the end of the season, and it may be a problem testing this. I'm thinking about trying to test it with the potential for snow in the Tidewater area this coming weekend. I don't think it's going to hit DC, but may try and find an airport to see how well it works, for a snowstorm, this upcoming snowstorm. But I think it looks promising, and at least it's an objective way of using model data to predict a snow range. I think it's probably going to be a little better way than some of the other techniques that I've used in the past. Okay, if you have any questions, just give me a tweet at PatPen, that's PATPEND, and I'll try and answer them. Thanks a lot.